So now that we've looked at solving linear trig equations, we're going to look at solving quadratic trigonometric equations. It will be useful to have your formula sheet with your addition, subtraction formulas, as well as the double angle formulas. So we're going to solve the following equation. 2 sine squared theta minus 3 sine theta plus 1 equals 0 on the interval x is between 0 and 2 pi. So the first thing I want you to do, I want you to identify what this equation reminds you of. It has 3 terms, and I want you to notice the degree is 2. So this looks very similar to equations in the form ax squared plus bx plus c. So we can utilize the standard form to help us solve this equation. Now notice, in terms of x, instead we have sine. So we can actually let x represent sine theta. So if we let x represent sine theta and we rewrite this equation, what would it look like? Well, it would look like 2x squared minus 3x plus 1 equals 0. This is an equation you've seen many times. So what I would like you to do now is factor this equation. You could use any method you like. And once you factor the equation, you should have 2x minus 1 and x minus 1 equals 0. Now that we've factored this equation, we need to remember that x right now represents sine theta. So in place of x, we're going to resubmit sine theta. So we're going to have 2x minus 1. And instead of the x, what is it going to become? It's going to become 2 sine theta minus 1. And then the x minus 1, in terms of the x, we replace it with sine theta. So we have a sine theta minus 1. So now we can solve for sine theta. So on this side, make this equal to 0. So sine theta equals 1/2. And then on this side, sine theta is equal to 1. So we have sine theta equals 1/2 and sine theta equals 1. So the next thing that we're going to do, we're going to find the exact values. So if we take a look at our axis, sine theta 1/2, theta is equal to pi over 6, or in radians, as decimal form, it would be 0.52. So what we can do is we can take pi over 6, or 0.52, and we're going to check the 2 quadrants where sine would be positive. So here and here. So in the first one, we simply have 0.52, or pi over 6. And then for the second one, what would we have? We would have pi minus 0.52, and that gives us 2.62. So in terms of theta, theta is going to equal pi over 6, or 0.52. Theta is also going to equal 2.62. Now, what would we do to write this as a fraction in radians? Well, we know that the acute angle is pi over 6, so we would do pi minus pi over 6. This changes to 6 over 6, so we have 5 pi over 6. So these are equivalent to each other, and then these are equivalent to each other. Now we also have sine theta equals 1. So where is sine theta equal to 1? Well, it's equal to 1 right here, which is at pi over 2. So theta equals pi over 2. So it's on the y-axis itself. Okay, so this time we have 2 secant squared theta plus tan theta minus 3 equals 0. So once again, this does look like it's in standard form. However, we have secant and we have tan. So what we want to do here, we want to get this equation in terms of just one trig ratio. Once we have one trig ratio, it'll be much easier to isolate and solve. So I want you to take a look at your double angle formula or your addition and subtraction formula sheet, and I want you to see if there's anything that we can change here so that we can write this equation in terms of one trig ratio. Usually the reciprocal functions are easiest to change. So secant squared theta is also equal to 1 plus tan squared theta. So we're going to rewrite this, and we're going to have 1 plus tan squared theta plus tan theta minus 3 equals 0. So now we have our equation, and we're going to use the distributive property. So we're going to have 2 plus 2 tan squared theta plus tan theta minus 3 equals 0. And now we're going to simplify, so we'll have 2 tan squared theta plus tan theta minus 1 equals 0. Okay, so once again, because we have tan theta and we want to factor this equation, just so it's easier on the eyes, easier to factor, we can let x equal tan theta. So we would have 2x squared plus x minus 1 equals 0. And then when we factor this, what are we going to get? We get 2x minus 1, x plus 1 equals 0. So now we have to replace x with tan. So we have 2 tan theta minus 1 equals 0. So tan theta equals 1/2, and then we have tan theta plus 1 equals 0. So tan theta equals negative 1. Okay, so now we're going to use tan theta equals 1/2 and check all possible answers. And then we're going to use tan theta equals negative 1 and check all possible answers. So in this first question, we're going to ask for tan theta equals 1/2. Where is tan positive? So tan would be positive here and here. And what is tan theta equals 1/2 in radians? Well, theta would equal 0.46, which is an acute angle, so this would be 0.46. And then how would we find this one? We would have pi plus 0.46. So we have theta equals 0.46, and theta equals, and then pi plus 0.46 is 3.6. So those are the two possible answers for tan theta equals 1/2. Now we need to check for when tan theta equals -1. Well, where is tan going to be negative? Tan is going to be negative in quad 2 and quad 4. And tan theta equals -1. Theta is going to equal 0.79, which is the acute angle. So for quad 2, we're going to do pi minus 0.79. And then for quad 4, we're going to do 2 pi minus the acute angle. So theta equals pi minus 0.79, which gives us 2.35, and theta equals 2 pi minus 0.79, which gives us 5.49. So for this question, because we're looking at when it's positive and negative, we have 4 possible answers. Okay, so you can have an infinite amount of answers here. All right. So for this next one, we're going to solve the equation 3 sine theta plus 3 cos 2 theta equals 2 on the interval x is between 0 and 2 pi. So first thing I'd like you to do, I want you to take a look at this equation and recognize what we can use from our formula sheet. Now notice we have cos 2 theta. The double angle for formula of cosine, well, there's multiple. Cosine 2 theta is equal to cos squared theta minus sine squared theta. It's equal to 2 cos squared theta minus 1. It's also equal to 1 minus 2 sine squared theta. So I want you to ask yourselves this: which one of these 3 would best suit this equation? And by best suit this equation, I mean which one would allow us to create an equation with the same trig ratios. So we have sine. So which one of these equations also has sine? Well, this one has sine, but it has cosine as well. This one, however, has sine. So we're going to replace cos 2 theta with 1 minus 2 sine squared theta. So it's going to look like this. So now we have 3 sine theta plus, and this is going to be 3, so plus 3, and then in brackets 1 minus 2 sine squared theta equals 2. So now we're going to expand and simplify. So we have plus 3 minus 6 sine squared theta minus 2 equals 0. And then we simplify this and put it into the form of standard form. We have negative 6 sine squared theta plus 3 sine theta plus 1 equals 0. So it's in the form ax squared plus bx plus c. So now we can factor. When you try and factor, you're going to notice that it's not working. It's because we have a decimal value. So we're going to use the quadratic formula. So our a value is -6, our b value is 3, and our c value is 1. So we have x equals -3 plus or minus 9 minus 4 times -6 times 1 all over 2 times -6. So this simplifies to give us -3 plus or minus root 33 all over -12. So our two possible answers, x can be 0.73 or x can be -0.23. So these are the two answers that are going to help us. Now remember, x is representing sine theta. So essentially, sine theta equals 0.73 and sine theta equals -0.23. So for sine theta equals 0.73, which two quadrants would sine be positive in? So we're going to check out quad 1 and quad 2. And then when sine theta equals -0.23, we're going to check out quad 3 and quad 4. Okay, so if we draw our sketch here, so we're going to check out sine theta equals 0.73. So put that into our calculator. We get theta equals 0.82, which is an acute angle. So we're going to have 0.82. And then we're also going to have pi minus 0.82. So theta equals 2.32 and theta equals 0.82. Now for the next one, we have -0.23. So when we find the inverse of sine, we have 0.23. Okay, that's the size of the angle, the absolute value. So now we're going to check out quad 3 and quad 4. So in quad 3, we're going to have pi plus 0.23, and quad 4, we're going to have 2 pi minus 0.23. So pi plus 0.23 gives us 3.37, and then 2 pi minus 0.23, theta equals 6.05. So our final answers are 2.32, 0.82, 3.37, and 6.05. So we have 4 answers. So remember, you can use x to help you look at your equation and factor it. Once you factor it, then you can replace x with either sine theta, cos theta, tan theta, whatever it may be. Then you can solve for theta.